In the preceding silent clip, I had this as dz, and it's really a delta z. Now, the delta z, the change in z, is going to be approximately equal to the x derivative times xu delta u plus xv delta v, etc., as we saw previously. If only u changes, then we don't have the delta v terms, and we see that delta z is approximately then equal to fx times simply xu delta u plus fy times yu delta u. Only the delta u terms will apply. Again, in the fact that in the case that only u changes, if v remains constant, so that our delta z over delta u is fx xu plus fy yu. Again, this is not hard to understand. It's the rate at which f changes with respect to x multiplied by the change in x. The change in x due to the change in u, which is just rate of change of x with respect to u times delta u. Each of these terms can be similarly deconstructed. When we divide through by the delta u, we see that z changes with respect to x at an approximate rate that's equal to fx times xu. How quickly does f change with respect to x, and then how quickly does x change with respect to u? The rate of change of f with respect to x multiplied by the rate of change of x with respect to u gives us a contribution to the change in z with respect to u. Okay, whether we understand that completely or not, it's well worth thinking about. And this leads us, now I made the change here at the end of the last clip. I had dz du and dz dv. And that was intentional. I wanted to emphasize that we do have partial derivatives. The idea being that this delta z over delta u is only part of the change in z. It's the part due to the change in u. So the partial derivative of z with respect to u, fx is just written partial f with respect to x, xu is partial of x with respect to u. We see we have the chain, looks like an algebraic or a multiplication of two fractions where we have some cancellation. Very convenient form in which to remember this, but we want to think about the meaning, which is why I didn't show you the form at the beginning. Didn't want you to get hung up on the form and think that we were multiplying fractions. There's a reason for this, but the convenient notation, the easy notation to remember is this. And then our fy is partial f with respect to y, our yu is partial y with respect to u. Again, the notation gives us an easy way to remember this. We get similar expressions in v, just completely analogous. And we go from the delta z over delta u to the dz du simply by letting delta u approach 0. This is again something that we'll do later with some rigor, using epsilons and deltas and so forth, and building up a good picture of what derivatives really mean, and also a way of understanding when they make sense and when they don't. Partial derivatives of z with respect to u and v. Again, partial of z with respect to u, partial of z with respect to v.